Good morning, everyone. How are we doing?
Good.
Wonderful. I just realized that I'm gonna, when I record, I'll just say the date so that I can keep it straight if I watch it later. So today is July 21st, and welcome to class, guys. And the plan is to work on 2.7, okay? But you can ask any questions anytime from things we have done in the past, okay? So don't feel bad about asking a question. It could be generic, like where's that, where's that? It could also be very specific. Can you do this? Can you do that? Now, anytime you can interrupt, and when you try to unmute yourself, I can almost hear it, so to speak. So feel free to do so anytime. Other than that, I plan on working on 2.7. And the good thing about 2.7 is that it builds on 2.6. And it's really, I don't think it's really that bad. Okay. Before we do that, and this is for everyone, people who are here and also for people who are not here, I'm going to go to my, let me share with you. Well, I won't go, but just to let you know, the exam is on Wednesday, on the 27th of July, of course, and you will get a day to take it. And I will give you now listen to me very carefully. I will give you 2 hours to take the exam. Okay. Generally, the university gives us 2 hours to take the exam, and I will add a few more questions. So there will be, let's say, 30 questions, 30, but you will get 2 hours. Be aware of that. And it will say in the bottom, nothing will be graded if you go past 120 minutes, which is 2 hours, just so that you know. A few more questions. I know most of you have been wrapping up in less than an hour, and that's what I kind of expect. You know, I will add at most 5 questions. Any other generic questions? And it says that in the study guide already. So make sure you're aware of it. Don't mess up. Don't miss the exam. I won't be able to do it. The grades are due the next day. I won't be able to give you a makeup exam. Another thing, guys, very important. Let me go to, you want to do your MATLAB soon. Let me see what the due date is. I won't be able to accept it because I have to grade it. They have been assigned a long time ago. Let me go to the course, okay? Let me go to the course page. That way, everything will be recorded. I'm going to enter my password. I'm going to just do stop share, okay? I'll share the screen in a minute. Okay, guys, so let's go to our MATLAB. Let's look at the dates. Okay, now we have a couple of sections to go, but just to be fair to you, all the assignments are due, I think, next week, sometime before the semester, before your exam, really, the last day of class. July 26th. You want to make sure, okay, listen to me very carefully. 2.7 is the last section I'm going to assign. Okay. I will do a couple of sections. We meet on Monday, we meet on Tuesday. I'll do some work, but I won't assign any MATLAB. If you want me to assign, if you are going to tell me, oh, give us some practice problems I like to practice, I will assign. If you want me to, you have to tell me clearly right now or via email. I will assign, but I'll make sure it's not graded. Okay, you want to practice, it's just for the people who want to practice. But my plan is I generally stop assigning homework so people can sort things through. So that's all the homework we're going to do. That doesn't mean we're stopping. We have 2 more lectures. We're going to go, I don't know how far we'll go. We'll have to continue. So the assignments are all here. They're due on July 26th. I won't be able to give you an extension, guys. Okay, so make sure you understand that. Any questions on the assignments and what I just said, guys? If you don't understand, not a bad time to ask. Make sure you do them before the 26th, and on the 27th, you will take the exam. All right, guys. Let's work on our next section. Okay, a couple of things. We're gonna learn about inverting a function. Okay, it's gonna, the only thing I don't, well, I shouldn't say I don't like this section. I like this section. Only thing that's challenging about this section is that it has a lot of symbolism. Don't let that bother you. Okay, it will gel. Okay, inverting a function. Before we can even invert, we will talk about something that we call one-to-one function. Try to understand it. I'm not going to ask you a question on this, okay? It's a very easy concept. 1 to 1. What does that mean? What's a one-to-one function? Okay, 1 to 1. Well, let me do this, guys. What's a one-to-one function? 1 to 1 function. Okay. Well, first, let me give you an example of a function that's not one-to-one. Of course, it has to be a function for sure, but what's not a one-to-one function? Let's go to Desmos. Okay. This function is not one-to-one. Sorry. Okay. Why? Why? Because when you enter, firstly, it's a function, it passes the vertical line test. Okay, so first you want to make sure it's a function, it passes the vertical line test. What is the vertical line test? If I draw vertical lines, none of my vertical lines will intersect the curve at multiple points. They intersect the curve at one point. So it's a vertical line test passes, it's a function. Okay, fine, that's a good sign. Now, it is not one-to-one because, and the good news is, if I enter -2, my value is 4. If I enter +2, my y value is also 4. So when I put 2 numbers, I get the same number. That's not a one-to-one function. Okay, here's another test for you. It's called a horizontal line test. If you can draw a horizontal line, let's write it down because this is a new term. What's a horizontal line test? If you can draw a horizontal line that cuts the curve cuts the function at multiple points, it is not a one-to-one function. So of course I can draw a horizontal line, many, it will cut my curve at multiple points. So it is not a one-to-one function. So I can only invert. I'm going to show you how to invert a function and what does it mean and why do we care? I will show you in a minute, but before we invert, we have to make sure the function is a one-to-one function. Now we know how to test if a function is a one-to-one function. What I have on the board, on the screen, is not a one-to-one function. Well, what about this one, guys? Let me clear all the writing, including horizontal line test. So what about this function? Does it pass the vertical line test? I'm going to hide this one. Do you think it passes the vertical line test? Sorry, horizontal line test. Can you draw a horizontal line that will cut your curve at multiple points? Can you draw a horizontal line, assuming it goes on and on, it goes straight up and straight down? Can you tell me if you can draw a horizontal line? Horizontal means left to right, parallel to the x-axis that will cut the curve at multiple points. What do you think?
Once, I think, just once.
Okay. You mean the x-axis right here? Is that what you mean, Jack?
Yeah.
Okay. It actually, go ahead. Who else is talking? I'm going to listen to you guys first. I heard another voice besides Jack's. Okay. Just to let you know, Jack, it's a little hard to see. It actually, if you zoom in, it only cuts this curve. It's hard to see, and it's not your fault.
Then I guess it's not. I guess it's not able
Exactly. It passes the horizontal line test, and it is a one-to-one function. Okay, it is a one-to-one function because every time you find an x value, there is only one y value. Let me see. Let me show you more, a little more. Okay, I'll show you one more. And again, I'm not going to give you a function that is not one-to-one and ask you to invert it. So you don't have, you should know it, but you don't have to worry about it too much. Let me draw one more. Okay, what about this one? Do you think the green line passes the horizontal line test and it is a one-to-one function? Can you draw a horizontal line that cuts this green line at multiple points?
No.
Exactly. So the answer is no, it passes the horizontal line test and it is a one-to-one function. Okay, I'll show you one more non-example.
So that's all this section is, just to find if it's a one-to-one function.
No. First, we will find out if it is one-to-one. And most of the questions we will see are one-to-one functions. And I will ask you to invert it, and we're going to learn about inverting a function. Okay, this is just the beginning, not the entire function, not the entire section. Let me draw one more where it's not. I can ask you to I can give you a curve and say, is this a one-to-one function? What do you think? Does it pass the horizontal line test? If it passes, no. It doesn't. Clearly it doesn't, because I can draw a bunch and I need to draw only one. I can draw one where it cuts the curve at 2 points. So if I give you a function like this, and we're going to do some problems from your book, and you will have to graph it and decide if it's one-to-one. Now, if I give you a question like that, it would be a relatively easy question. Okay, we're going to look at the problem, then you'll see. I'll clearly tell you what kind of problems I'll give you. So don't worry too much about it. I'm not going to ask you to invert a function that is not one-to-one. The question is, how do we invert and why do we invert? Okay, last class we talked about composition of functions. It's kind of related to that. But before we get to that, let's talk a little bit about how do we invert a function. Okay, just the process, nothing fancy. Nothing fancy, just the process. And we're going to tell you why do we care and all that. Well, its compositions are interesting. People are interested in it. That's why. Now, they say a lot of cool things here. Okay, guys, right here. And they say a bunch of interesting things, and it won't make a whole lot of sense, but I'll do the thing and I'll tell you, I'm doing number one, I'm doing number two, so on and so forth. So let's invert a function, and let's start with something that is already one-to-one. Okay, I'll do some of these problems for you. Okay, let's take something very simple. I assigned you 15 through 28. I have some easy problems here on top for us to see, but let's do number 16. So the question says, find the equation for f inverse. Okay, we're going to tell you what that is in a minute. F to the power -1 is, we call it inverse of x. This is red, inverse of x, or f of x, I'm sorry. This is your main function. Its inverse is written like this. Okay, I can say this is f of x, find this. It's another way of saying find the inverse of f of x. So in our case, I'm going to grab my f of x. And to convince you that it's one to one, I will graph it. But again, if they ask you to find the inverse, that means it is 1 to 1. You don't have to graph it. But let's do 16 and let's convince you first that this is 1 to 1. Okay. And it's going to be a straight line, 3x minus 1. And we're going to check it. You don't have to check it. Okay. If I ask you to graph something that's find the inverse of something that's not 1 to 1, that's going to be my fault, not yours. It's a straight line. 3x minus 1 is a straight line. And what happens with straight lines? Well, there's certainly, if it's not a horizontal straight line, it will pass the horizontal line test, and that will make it a 1 to 1 function. So we're good there. All right, so let's invert it. Let's find, you can say it in two ways, okay? You can say, let's invert the function. You can say, let's invert the function. Both are correct. Or you can say, let's find the inverse of the function, your choice, okay? We can use both expressions. Invert the function. Let's find the inverse of the function. Both are acceptable. I switch around. Don't let that confuse you, okay? Both are acceptable. I'm going to erase this because I need the rule. All right, guys. So the rule here is replace f of x with y, okay? We are going to say y equal to 3x. Then interchange x and y. I'm going to do it using a different color. Don't say equal. Instead of y, write x. Instead of x, write y. And everything else stays the same. Now, solve for y. Solve for y is another way of saying isolate y. Express y in terms of x. How do you do that? Well, that's not too difficult. You're gonna leave your 3y here, bring your 1 on the other side. On the right hand side, you can have this. Now I'm going to switch things around because I want my y to be on.
Wait, Professor, why does y go over to the 3 and x goes over to the equal?
Okay, sure. Let me erase this. All right. Okay, this is a method. How do you find inverse of a function? Okay, the first one is step 1 is you replace.
Oh, I see it.
Do you see it? The second
Yeah.
step is replace x with y, y with x. So let's do it.
Okay.
Y will become x. It's just step 2. It's a rule. It's a rule that works. And now the third one is solve for y. You solve for y using the green equation. Are you okay, Jack?
Yeah, I get it.
Good. Okay, now when we solve for y, some people say isolate y or express y in terms of x. Either way, I'm going to write it. I'm not going to change any signs. I'm just going to say this is equal to this. They're equivalent. I can say that. It's a legal step. I'm going to divide both sides by 3. Finally, instead of y, you're going to write f of inverse x. Finally, okay?
You put it 2, Professor.
Yes, thank you. Thank you very much. All right. Now, instead of y, let me push it up. Instead of y, I'm going to do a couple, so don't panic too much yet, okay? F inverse x is equal to x plus 3, x plus 1 divided by 3. Okay, so this was given, and this is something you calculated, and this new function x plus 1 over 3 is called the inverse of f of x, or it's f of x inverted, however you want to say it. Now let's see what it looks like if I graph this. I already graphed this to convince you this is 1 to 1. It passes the horizontal line test. I would also graph this and show you why do we care. And I have to draw it nicely. It's x plus 1, the whole thing divided by 3. I'm going to call it g of x, which is the inverse x plus 1 divided by 3. Okay, so guys, look at the purple one. What is going on here is this. This is interesting. Okay, f of x, the blue one, is my original function. G of x, I don't know if it's gonna let me do the -1. Oh, it does. Awesome. So, oh, it didn't. So anyway, I'm not going to worry about it. Maybe it does, maybe it doesn't. But g of x is the inverse because we calculated it. What's the relationship between the original f of x function and the purple inverted or inverse of f of x? Well, it has a very strong relationship. If you draw a line right through the origin and right through the middle, okay? If you draw a line right through the origin, right through the middle, the equation of this line is y is equal to x. You will see this purple function is a reflection of the blue function. And this is an important property. The reason it's important, guys, when you find the composition of these two functions, you get the constant function, the pink function. Now, here's a little bit of theory. Okay, you might wonder, why do we care? Because this has a nice property. People like interesting properties and they study these things. So that's that. Now on the exam, again, I will ask you to just invert the function, and you should know a good way to check is, and I will check for you, every time I invert something, I'm going to graph both. And this graph will always be, one will be a reflection of the other, and this, the pink line that I drew is really y is equal to x line, this black line. You will always see this is the original function is blue and the purple function is the inverse, and they reflect each other along the black line. Do you have to tell me all these things on the exam? Not really, but you have to know how to find the inverse. I'm going to pause there a little bit. And here are my graphs. Here is my work. I will do a couple more for sure. And you will see a problem like this on the exam. And on the exam, when you write it, and you have to write it nicely, and let's go find out how to enter it nicely on BlazeView. Okay, and I'm not hiding this. This is not going to go anywhere. Let's see, because I'm going to learn today too, because I don't know if it can be done. I hope it can be.
Professor.
Yes.
Can we
Sure.
write the inverse f of x
Mhm.
equals x
Plus
plus
1.
1/3 as the answer?
Correct. Correct.
Okay.
If I ask you to find the inverse of this function, and I
Okay.
expect you to write something like this, and we'll do a few more. Let's find out about this. Let's go to open one of our exams. I'm working on your final, and not that you can see it, but it's really here. Let's do no credit exam 3. Okay, it's something you've seen. And let's say preview, start quiz. And I'm just going to randomly enter an answer, okay? I know it's doable, even though I haven't done it. I'm going to go to equation. I'm going to go to graphical equation. So I'm going to go to f to the power -1, jump out of the power sign, put x equal to x plus 3 over, I don't know what we had, but we had something, x plus 1 over 3. There you go. Okay, it's all there. It's not too bad. Now, you have to write the whole thing, guys. Okay, just don't give me x plus 1 over 3 and write it properly. All right, so it's here. It's being recorded. So we have it. Now, let's get back and see if we have any question about this or this. We'll do a few more. We're not finished. Okay, guys, let's try one more. Let's try one more from your text. Let's try number 17, okay? I assigned you up to 20. Well, 17 you'll be able to do, but 17 is almost too easy. I'll try a couple, but I'll try it since I said that, okay? It's not bad at all. Here is 17. I'm going to erase everything here. Okay, now if you don't mind, guys, I don't even need this. Okay, this little, I need the room. I'm going to do the same thing, okay? If you need those rules, I'll bring them here, but a little extra room wouldn't hurt. First, the rule of our little step here says, oh, let's bring it here today for the last time. Then we'll just do it like we know it. Okay, so what does it say? Replace f of x with y. Okay, let's do it. Step 1. Then it says, interchange x and y. So I'm going to change the color. That means it's a completely different thing now. Instead of y, I'm going to write x. Only replace x with y and y with x. Nothing else changes. Now I have to isolate y. Now I show all the steps. Some of you will skip this step. This almost seems redundant. Okay, then I'm going to find, to isolate y, I'm going to take cube root of both sides. Taking cube root has to be done carefully. Don't leave it like this. Put a little 3 here. Okay. And how do you do that so we're not done, but we're going to replace y with this guy. Now, if you don't mind, I'm going to go show you. Most of you are trying and entering your answer nicely, but some of you are still struggling. I'm going to show you.
Professor,
Go
how
ahead.
does it turn to 3?
I know. I've been very bad.
Oh, you're good. You're good.
Thank you. Thank you very much. All of a sudden it changed. Is that any better?
Yeah, that's better.
Awesome. Thank you for catching my mistake. So that's my answer. Okay. I'm going to pause here a little bit. Okay. That's my answer. That's my inverted function, or that's my inverse. I'm going to enter it in a minute, but let's graph the two and let's see if it is reflective. Okay. Why do you want to know it, guys? It's a good way for you to check. I'm glad Jack caught me, but on the exam, nobody will catch you, right? You can graph it and see if they reflect. So let's try it. X cubed over 3, and then you go back, you make a mistake, you go back and you say, well, what did I do? That's wrong. And cube root of x minus 2. Okay, cube root can be entered like this. Okay. I know it's a little hard to see, but it is a reflection along the line y is equal to x. It's nice to know the line should be y equal to x, and you can enter it there too. You can do it by hand, but I would just enter it. You have Desmos. See, it's a beautiful curve. Look how nice it looks. Looks like a pen, nib of a pen. But so our answer is right. Okay, I was wrong, but I was fixed. Thank you. But our answer is right. So you really want to check your answer. You don't want to get an answer and move on. Now let's see how we can enter it. Okay, guys? How do I enter this properly during our exam? I'm going to erase this. So this is old news. We have done it. -1. And don't put a prime, guys. You want to put -1 carefully. And this was cube root. Okay, cube root. This is cube root of x plus or minus 2. I don't even remember, but I'll check. It was -2. Just a moment, guys.
Hello?
Just a moment. Hey. All right. Okay, I'm not gonna upgrade it, but let's do it this way. 3. Do we see it, guys? What do you think? Are people here? Can you still hear me, guys?
Yes, yes, we can.
Okay. What does this look like? Sorry about
That's the inverse equation.
Right. Okay. So going back, I'm going to pause here a little bit to see if we have any questions. This one is the main problem. This one is a test that you want to do. Okay. Just be aware of that. I won't ask you to graph it. Okay. Because there's no way you can turn in your graphs. So let's pause here a little bit. It's going to kick me out anytime, but it's not a big deal. I think we can squeeze in one more problem in this session. That way we can kind of expand our. Again, practice some, go to MATLAB, do some of those problems. It's really not that bad. The steps that I'm putting right in front of me will be in front of you. Okay, so it's just doing it right. Let's do one more before we are kicked out. Let's do one more. Well, let's do one like 25. Okay, that's hard. Okay, and you're going to see some of these. So let's patiently do it. Again, guys, if I'm kicked out, always come back unless we say goodbye properly. Well, let's do 28. There, well, yeah, 28 is probably the hardest in this group. Let's do 28. Okay, again, you have to be a little careful. I'm not going to use this anymore. Okay. Okay. So guys, the first rule is you replace f of x with y. I didn't do anything, right? It's the same one. Now I'm going to change color. So once you replace x with y, y with x, it changes. The function is a new function. So y will be x and x will be y. Okay, now, sorry. This will be y. Okay, now isolating y is a little tricky here. Okay, that's why I need the extra room. So first I'm going to multiply both sides by y plus 1. It's called cross multiplication. That's the term we use. Everybody calls it something else. I'm going to multiply. I'm going to go here. And I'm going to go back to switch to my green. It doesn't matter, really. It's going to be a little bit of work, so be a little patient. But it's very rewarding when you graph it and they nicely match. It looks good. All right. Now, I'm going to distribute x over. All right. Now, remember, guys, I am isolating y. Okay, not x. I'm going to put y on the same side. I'm going to bring this y here. And I'm going to bring this x here. Doesn't matter how you say it, but you want to do it right. X, y is here. I want to keep y on the left-hand side. 2y becomes minus 2y because it moved sides. X becomes minus x. Minus 3 is already here. I didn't do anything with it. Okay. Now I'm going to factor out y from the left-hand side. Remember, I'm isolating y. I'm going to leave it like this. Some people will write 3 plus x times minus 1 and all that, but it's good enough for me. I'm going to divide both sides by x minus 2. Okay, now I'm almost done, guys. That's my answer. I already have my answer, but I'm going to write it properly. And the best thing will be the test. Do they reflect each other? If they do, it's quite likely I'm correct. All right. So guys, I will be happy to give you some time. We still have 4 minutes here. I'm going to quickly graph them very carefully. 2x minus 3, x plus 1 here. 2x minus 3. It's not fun. We'll fix it. Okay, guys. Okay, I don't need this. Okay. All right, so f of x is 2x minus 3 plus divided by x plus 1. Let's check 2x minus 3. Okay, fine. This one is 3 minus x, x minus 2. Minus 3 minus x. If you want to write minus 3 first, be my guest. Doesn't make any difference. And x plus 2. X plus 2. All right, let me see what's going on here. Okay, this will be a little, let me double check. Minus 3 minus x, x minus 2. Okay, that looks a little better now. All right, so so it actually works, okay? So very carefully, the blue function and the red functions are reflections. How will I convince you? Take a look at this one. This guy really nicely reflects here, and this guy reflects here. It's a little hard to see, but one of the good things about math, when things are this complicated, they won't match even this much, so it is correct. Okay, this blue part matches this one, and this blue part matches this one. So yes, this is a reflection of each other. So we have it, we have our answer right. So that's how you can check your answer. And we're back here, guys. Let's pause here a little bit. Let's see if you have any questions about the math. You want to copy, you want to do all that, that's totally fine. Okay, guys, this will kick me out in less than a minute. Let's get out of this. I'll save the slide for you guys, okay? Let's get out of this session and come back. We're not going anywhere. We're going to continue our work. See you soon, guys.